Let's make the program that reverses a string. We'll start with our program setup and add a string to the data section. A very common way to denote the end of a string is by adding a null character at the end, which is just the value 0. Our program will use the null character to know when it is done iterating through the string. We'll first move the address of the first character in the string into RDI. We'll create a loop by adding a label to the beginning and a jump command at the end that jumps to the label. Also, at the end of the loop, we'll use the increment command to add 1 to RDI, which means it's now pointing to the next character in the string. Then, we'll add some code at the beginning of the loop that will conditionally break from the loop. Registers are 8 bytes large, but we just want to get the byte stored at the address that RDI holds. This means we just want to move the character into the lower byte of RAX. Let's quickly take a look at the different subsections of a register. In this example, I'll show the RAX register, but it applies to all registers. As we've seen, the entire 8 bytes are called RAX. The bottom 4 bytes are called EAX. The bottom 2 bytes are called AX. AX is split into two sections, the higher byte AH and the lower byte AL. So in our program, we will move the character into the lower byte of RAX by writing AL. We then compare the character that AL holds to the null character, and if the values are equal, we jump out of the loop. If the character is valid, we push the character onto the stack. Because the stack can only add or remove 8 bytes at a time, we push using RAX, not AL. After the first loop, we set the second loop up the same way. Because we only need to read the character once, we won't move it into AL. When we compare the character to the null character, we must write byte in front of it. Before, when we move the value into AL, the assembler could assume the number of bytes to transfer because we specify the size of the register. Now we must explicitly state the size so it knows how many bytes at the address to compare to the null character. We compare the character to the null character to check if the end of the string has been reached. If it has, we jump out of the loop. Otherwise, we pop a character off of the stack and replace the current character in the string with that value. We'll end the program by printing the reverse string using our write macro and then exit the program.